So before moving to the coding for epoch with 15 epochs, I wanted to mention our work distribution. So Brother Hanif did the coding for EDA and RNN with RNN LSTM with 5 epochs. Brother Ahmad and Noman did this code, which is RNN LSTM with 15 epochs. I am Abid. I did the report and the voice recording of this video and the presentation slide, and this is it. So in order to keep both of our model and evaluation as competitive and justified, so we didn't change all the other thing. What we change is we only change the number of epochs and we add some more evaluation technique. So if you can see that all of these are similar like the one I showed before, all the data collection, and the only change occur in this code is this one, and the following are some of the evaluation measures. So we increase the epoch here as 15 and all of the rest are similar. Just brother Noman, brother Mahfuz add MSE instead of in previous example it was only accuracy. So instead of metrics he wanted to see mean square error as well. So when he run the model, it can be seen that he got accuracy around 62.8% and his RMSE of RNN model is 0.27%. So if we go into his confusion matrix, and the model can predict laying, sitting and standing correctly as we mentioned in our presentation slide as well, but the problem arises when the model tries to differentiate between walking upstairs and walking downstairs. Even in this scenario you can see that in the standing, the standing is, if you combine all of this and divide the summation with 420, it can be seen that even the standing is not that accurate. So what brother Ahmad and brother Noman did is they tried to find out why this is happening. So using this graph we can see that in this section we have the loss or accuracy values, in this section we have number of epochs. So as the number of epochs are increasing during the RNN with 15 epochs, so we can see that the accuracy was started to climb until epoch number 3, then it started to drop and it continued with around 60%, and at the end it dropped pretty low. But the main issue occurs when this is the trend loss, the blue line. So you can see that after the third epoch the loss is continued to rise steadily. So from here we can understand that because of the incapability of RNN to go to the trace back, so he is losing data fast and losing the accuracy as well. In the next step, he wanted to find out the precision, recall as well, and F1 score as well. So we can see that our precision for laying is quite high, sitting is also acceptable, but the standing precision is quite poor. Even the recall is acceptable, but the F1 score is pretty poor as well. And the rest three, walking downstairs and walking upstairs, is pretty bad. Even walking downstairs, there is not even single case identified that this event would be walking downstairs. So that's why it was missing from here in the graph. So if we sum them up, it will give pretty bad result because of there is no activities identified as walking downstairs, and the mean average would be around 56%. Now we are using all of this code as running, because if we run all of this code, it takes at least 20 to 25 minutes to get all the values. So that's why it was we are just planning on the given result is there. We will attach the IPython code as well as the Python code in the submission folder. So here brother Noman and Ahmad tried to find out the ROC curve. So from the ROC curve we can see that our area under curve would be around 70%, approximately 70%. Sorry, my mistake, as it is saying here that ROC curve area is 93%. So this is just the stage we printed out, that what we did after our input. These were all the 4 stacked RNN, then the dropout layer was applied, then the dense layer and the output layer. So here we build the LSTM model with 15 epoch as well, and all the rest were same. Now if we come to the model score, it scored around 84.22%, and the RMSE was 0.18%. If you see from above, it is lower than RNN. The RMSE for RNN was 0.277%. So RMSE is another evaluation matrix. We can say that if the RMSE is low for LSTM, that means it is performing better than RNN. Let's look into the confusion matrix. So in this scenario, the laying activity was recognized well. Only the problem around it was when it performed moderately was the standing. So after we go down, so from the confusion matrix we can say that our model performed as expected, but there are some areas to improve as well. So similarly, if we want to plot the graph from RNN, which we did in RNN, so we can see that why LSTM model perform better is from the beginning, as the epoch is increasing, the train losses is going down, and as the epoch is increasing, the train accuracy is climbing steadier. So that's why the LSTM model perform much better than the RNN. Similarly, if we look at the precision recall and F1 score, we can see that for all of the activity the model performed pretty well. Only the value under 79, under 80 was the standing. So that's why the average of this model was around 90%. The precision recall and F1 score all become pretty similar. Now if we plot the ROC curve, it is saying that the area under curve is 98%, so it's probably it means that 98% of the activity is properly recognized. And if we go further, it is just our LSTM model. So from these performance metrics we can say that our LSTM model perform much better than the RNN. And this was our code demo. Thank you very much. Assalamu alaikum.